Welcome to our exploration of renewable energy technologies, the driving force behind the future of sustainable power. As the world faces growing concerns about climate change and the depletion of fossil fuels, the need for clean, reliable, and renewable sources of energy has never been more urgent. In this video, we'll journey through the most promising renewable energy technologies, examining how they work, their benefits, and their role in shaping a greener tomorrow. Let's begin by understanding what renewable energy truly means and why it's so crucial for our planet's future. Renewable energy refers to power generated from natural resources that are constantly replenished, such as sunlight, wind, water, and geothermal heat. Unlike fossil fuels, which are finite and contribute to environmental pollution, renewables offer a sustainable and cleaner alternative. These resources are naturally occurring and can be harnessed repeatedly without running out. As we move forward, understanding the core principles of renewable energy will help us appreciate the technologies that make sustainable power possible. Sustainability is at the heart of renewable energy. Our planet's resources are limited, and the environmental impact of traditional energy sources is becoming increasingly severe. By shifting to renewable technologies, we can reduce greenhouse gas emissions, combat climate change, and preserve natural ecosystems for future generations. Sustainable power isn't just about energy, it's about creating a balanced relationship between human progress and environmental stewardship. Solar energy is one of the most widely recognized forms of renewable power. By capturing sunlight and converting it into electricity using photovoltaic cells, solar panels provide a clean and abundant energy source. Solar technology has advanced rapidly, making it more efficient and affordable than ever before. Whether installed on rooftops or in large solar farms, this technology is transforming how we generate and consume electricity. Solar panels are made up of many photovoltaic cells that absorb sunlight and generate direct current DC electricity. This DC electricity is then converted into alternating current AC by an inverter, making it usable for homes and businesses. The process is silent, emission-free, and requires minimal maintenance. As solar technology continues to evolve, efficiency rates are climbing, making solar power a key player in the renewable energy landscape. Solar energy isn't limited to electricity generation. It's also used for heating water, powering vehicles, and even providing energy in remote locations where traditional power grids are unavailable. From residential rooftops to massive solar farms, the versatility of solar technology is helping communities worldwide access clean, reliable power. As costs continue to fall, solar is becoming an increasingly attractive option for both individuals and businesses. Wind energy harnesses the natural movement of air to generate electricity. Modern wind turbines, both onshore and offshore, capture kinetic energy from the wind and convert it into usable power. Wind farms are now a common sight in many countries, providing a significant share of renewable electricity. As turbine technology improves, wind energy is becoming more efficient and accessible, playing a vital role in the global shift towards sustainable power. Wind turbines consist of large blades mounted on tall towers. As wind blows, it turns the blades, which spin a shaft connected to a generator. This mechanical energy is then converted into electricity. Modern turbines are designed to operate efficiently even at low wind speeds, and advancements in materials and design are making them more durable and cost-effective. Wind power is a clean, renewable solution with a small environmental footprint. Wind energy offers several key advantages. It produces no emissions, requires no fuel, and can be deployed at various scales, from small community projects to large commercial wind farms. Wind power also creates jobs in manufacturing, installation, and maintenance, supporting local economies. As technology advances, wind energy is becoming more reliable and cost-competitive with traditional energy sources. Hydropower is one of the oldest and most established forms of renewable energy. By using the movement of water, typically from rivers or dams, to spin turbines, hydropower plants generate electricity on a large scale. This technology is highly efficient and can provide a steady, reliable source of power. Hydropower also offers the ability to store energy through pumped storage, making it a valuable asset for balancing supply and demand. There are several types of hydropower systems, including run-of-river, reservoir, and pump storage. Run-of-river systems use the natural flow of rivers, while reservoir systems store water in dams for controlled release. Pump storage allows excess electricity to be used for pumping water uphill, which can then be released to generate power when needed. Each type has its own advantages and is suited to different environments and energy needs. While hydropower is a clean energy source, it can have environmental impacts, such as altering river ecosystems and affecting fish populations. Modern hydropower projects are increasingly designed with environmental considerations in mind, including fish ladders and improved water management. By balancing energy production with ecological protection, hydropower can remain a vital part of the renewable energy mix. Thermal energy taps into the Earth's natural heat, using it to generate electricity and provide heating. This renewable resource is available year-round, regardless of weather conditions. Geothermal power plants extract heat from deep underground, converting it into usable energy. With minimal emissions and a small land footprint, geothermal energy is a reliable and sustainable option for many regions. Geothermal systems use wells to access hot water and steam from beneath the Earth's surface. This heat is used to drive turbines and generate electricity, or to provide direct heating for buildings. Enhanced geothermal systems can even create artificial reservoirs to expand access. The technology is highly efficient and can operate continuously, making it a valuable addition to the renewable energy portfolio. Geothermal energy offers several unique advantages. It provides a constant, reliable supply of power, is largely immune to weather fluctuations, and produces very low emissions. Geothermal plants also have a small land footprint compared to other energy sources. As technology advances, more regions are discovering the potential of geothermal energy to meet their sustainable power needs. Biomass energy is produced from organic materials such as plants, agricultural waste, and even municipal solid waste. By converting these materials into electricity, heat, or biofuels, biomass offers a renewable way to recycle waste and reduce landfill use. Modern biomass technologies are designed to minimize emissions and maximize efficiency, making them an important part of the sustainable energy landscape. Biomass power plants burn organic materials to produce steam, which drives turbines and generates electricity. Alternatively, biomass can be converted into biogas or liquid biofuels for transportation. Advanced technologies are improving the efficiency and environmental performance of biomass systems, ensuring that they remain a sustainable and flexible energy option for the future. Biomass energy has the advantage of utilizing waste materials and providing a renewable alternative to fossil fuels. However, it's important to manage resources sustainably to avoid deforestation and ensure that emissions are minimized. When implemented responsibly, biomass can play a significant role in reducing our carbon footprint and supporting a circular economy. Ocean energy technologies, including tidal, wave, and ocean thermal energy, are gaining attention as promising sources of renewable power. By harnessing the immense energy of the world's oceans, these technologies have the potential to provide reliable, large-scale electricity generation. While still in the early stages of development, ocean energy could become a major contributor to the global renewable energy mix. Tidal power uses the rise and fall of ocean tides to generate electricity. Tidal barrages and underwater turbines capture the kinetic and potential energy of moving water, converting it into power. Tidal energy is highly predictable and can provide a steady source of electricity, especially in coastal regions with strong tidal flows. Wave energy devices capture the up and down motion of ocean waves and convert it into electricity. Various designs, such as oscillating water columns and floating buoys, are being tested around the world. As research progresses, wave energy could become a significant source of clean, renewable power for coastal communities. Ocean thermal energy conversion, OTEC, uses the temperature difference between warm surface water and cold deep water to generate electricity. This technology is particularly suited to tropical regions and has the potential to provide continuous baseload power. While still in development, OTEC represents another innovative approach to harnessing the ocean's vast energy resources. As renewable energy sources like solar and wind are variable, effective energy storage solutions are essential for ensuring a stable power supply. Technologies such as batteries, pumped hydro, and thermal storage allow excess energy to be stored and used when needed. Energy storage is a key enabler of a reliable and resilient renewable energy system. Modern battery technologies such as lithium-ion and flow batteries are revolutionizing energy storage. These systems can store large amounts of electricity for use during periods of low renewable generation. As battery costs decrease and performance improves, they are becoming an integral part of the transition to a renewable-powered future. Integrating renewable energy into existing power grids presents unique challenges. Variability in supply, grid stability, and the need for advanced control systems all require innovative solutions. Smart grids, demand response, and improved forecasting are helping to overcome these obstacles, paving the way for a more flexible and efficient energy system. Smart grids use digital technology to monitor and manage electricity flows, enabling better integration of renewable energy sources. These systems can automatically balance supply and demand, detect outages, and optimize energy use. By making the grid more intelligent and responsive, smart grids are essential for a sustainable energy future. Distributed energy systems involve generating power close to where it's used, such as rooftop solar panels or small wind turbines. This approach reduces transmission losses, increases energy security, and empowers communities to take control of their energy needs. Distributed systems are a key trend in the evolution of renewable energy. Microgrids are small, self-contained energy systems that can operate independently or alongside the main grid. They often incorporate renewable energy sources and storage, providing reliable power during outages or in remote locations. Microgrids are increasingly being used to enhance resilience and support the transition to clean energy. Renewable energy is transforming transportation through electric vehicles, EVs, biofuels, and hydrogen fuel cells. EVs powered by clean electricity reduce emissions and dependence on oil, while biofuels and hydrogen offer sustainable alternatives for aviation and shipping. The shift to renewable-powered transport is a major step toward a low-carbon future. Adoption of electric vehicles is accelerating worldwide, driven by advances in battery technology and supportive policies. EVs offer lower operating costs, zero tailpipe emissions, and a smoother driving experience. As charging infrastructure expands and renewable electricity becomes more available, EVs are set to play a central role in sustainable transportation. Biofuels made from organic materials and hydrogen fuel cells are providing new options for decarbonizing transport. Biofuels can replace gasoline and diesel in existing engines, while hydrogen offers a clean fuel for heavy-duty vehicles and long-distance travel. Both technologies are advancing rapidly, opening new pathways for sustainable mobility. Industries are increasingly turning to renewable energy to power their operations and reduce carbon footprints. Solar, wind, and biomass are being used for electricity, heating, and even process fuels. By adopting renewables, industries can lower costs, meet sustainability goals, and enhance their reputation with environmentally conscious consumers. Decentralized power generation involves producing energy at or near the point of use, rather than relying on large, centralized plants. This approach increases resilience, reduces transmission losses, and supports the integration of diverse renewable sources. Decentralization is a key trend in the evolution of modern energy systems. Community energy projects empower local groups to develop, own, and benefit from renewable energy installations. These projects foster collaboration, create local jobs, and keep energy revenues within the community. By involving citizens directly, community energy is helping to democratize the transition to sustainable power. Government policies and regulations play a crucial role in accelerating the adoption of renewable energy. Incentives, feed-in tariffs, and renewable portfolio standards encourage investment and innovation. Clear, supportive policies help create a stable environment for the growth of sustainable power technologies. Global cooperation is essential for advancing renewable energy technologies. International partnerships enable the sharing of knowledge, resources, and best practices. By working together, countries can accelerate the deployment of renewables and address common challenges, such as climate change and energy security. Investment in renewable energy is growing rapidly, driven by falling costs and increasing demand for clean power. Both public and private sectors are funding new projects, research, and infrastructure. As investment continues to rise, renewable technologies are becoming more competitive and accessible worldwide. Renewable energy sector is a major source of new jobs, from manufacturing and installation to research and maintenance. As the industry expands, it offers opportunities for workers in a wide range of fields. Investing in renewables not only benefits the environment but also supports economic growth and workforce development. Ongoing innovation and research are driving the evolution of renewable energy technologies. Scientists and engineers are developing more efficient solar panels, advanced wind turbines, and smarter energy storage solutions. Continued research ensures that renewable energy will remain at the forefront of the global energy transition. Despite rapid progress, renewable energy faces challenges such as intermittency, high upfront costs, and regulatory hurdles. Addressing these barriers requires coordinated efforts from governments, industry, and communities. With the right strategies, these obstacles can be overcome, paving the way for a sustainable energy future. Consumers play a vital role in the renewable energy transition. By choosing green energy options, investing in rooftop solar, and supporting sustainable products, individuals can drive demand for clean power. Consumer awareness and engagement are key to accelerating the shift toward a renewable-powered world. Education is essential for building public support for renewable energy. Schools, media, and community organizations are helping to raise awareness about the benefits of sustainable power. By informing and inspiring people of all ages, education is laying the foundation for a cleaner, greener future. Future of renewable energy is bright, with emerging trends such as digitalization, artificial intelligence, and sector coupling. These innovations are making energy systems smarter, more flexible, and more integrated. As technology continues to advance, renewables will play an even greater role in powering our world. Renewable energy is transforming economies, improving health, and reducing environmental impacts worldwide. By providing clean, affordable power, renewables are helping to lift communities out of poverty and create a more equitable world. The global impact of sustainable power is profound and far-reaching. As we've seen, renewable energy technologies are at the forefront of the transition to sustainable power. From solar and wind to emerging ocean and storage solutions, these innovations are reshaping how we produce and use energy. By embracing renewables, we can create a cleaner, healthier, and more prosperous future for all. The journey towards sustainable power is ongoing, and every step forward brings us closer to a brighter tomorrow.